Hello and welcome. In the previous lesson, we studied the upper bound for a set of real numbers. In this lesson, we will study the lower bound for a set of real numbers. At the beginning, if we have a set S of real numbers, and there exists a real number, let be L, such that for an element X belongs to the set S, X is greater than or equal to L, then L is called a lower bound of S. Thus, if there exists a lower bound for any set of real numbers, then this set is said to be bounded below. For example, on the line of real numbers, let S be an interval of real numbers, and X belongs to S, and X is greater than or equal to L. So, S is said to be bounded below, and L is called a lower bound of S. The set of positive real numbers is an example of the set which is bounded below, where 0 is a lower bound of it, while the set of negative real numbers is not bounded below. So, we can conclude that it is not necessary that a set should be bounded below. And if the set has one lower bound, then it has many lower bounds. That is, if L is the lower bound of S, then every real number less than L is also a lower bound of S. Moreover, if the set of all lower bounds of the set S has a greatest member, let be W, then W is said to be a greatest lower bound, or an infimum of S. So, a real number W is the infimum of S if two conditions hold. For all X belongs to S, X is greater than or equal to W. And for each positive real number epsilon, there is a real number X belongs to S, such that X is less than W plus epsilon, and the infimum of S is unique. That is, a set cannot have more than one infimum. To prove this property, let W1 and W2 be two infimum of the set S. Then, W1 and W2 are both lower bounds of S. And since W1 is an infimum of S, and W2 is a lower bound of S, therefore, W1 is less than or equal to W2. And also, in the case of W2 is an infimum of S, and W1 is a lower bound of S, so W2 is less than or equal to W1. Then, by the law of trichotomy, this implies that W1 is equal to W2. So, the infimum of a non-empty set of real numbers that is bounded below is unique. Exercise. Find the infimum of this set. Pause the video and try to solve this exercise. The solution. The smallest element in this set is 1. And any number less than 1 is not a lower bound of this set, because all elements of the set are 1 or greater. Where, for all n belongs to the set S, n is greater than or equal to 1. Therefore, 1 is a lower bound of S. And also, 1 is the greatest lower bound of S, where, for any positive real number epsilon, there is a real number n belongs to S, such that n is less than 1 plus epsilon, thus, the infimum of S is 1. Now, our lesson of today is finished. See you later in the following lesson.